Let us see the question from exercise 5.1, problem number 33. Angle A and angle B are acute angles such that cos A equal to cos B. Then show that angle A equal to angle B. Let us consider one triangle ABC in which C is equal to 90 degree. A and B are given as acute angles. Let us find out the value of cos A and cos B with respect to this triangle. Definition of cos ratio is adjacent side upon hypotenuse. So, applying the formula, adjacent side will be for angle A is AC. Hypotenuse obviously is opposite to right angle, that is AB. Same way for angle B, adjacent side will be BC, hypotenuse will be AB. Since cos A and cos B are given equal to each other, that is LHS are equal, equating the RHS, we get AC upon AB equal to BC upon AB. Cancelling the common element, that is dividing both sides by AB, what I am going to get is AC is equal to BC. Since the two sides of the triangle are equal, apply our isosceles triangle theorem, which says if two sides of a triangle are equal, angles opposite to them, that is opposite to AC, angle B, opposite to side BC is angle A, will be equal to each other. Thus we have proved angle A and angle B equal to each other. So pretty simple question. The next question is 5.2, problem number 29. It is given that sine of A minus B is sine A cos B minus cos A sine B, and cos of A minus B is cos A cos B plus sine A sine B. Actually, these are the formulas which you will learn in 11th standard. Then we have to find the value of cos 15 and sine 15. Now either we will find out the value of cos 15 or sine 15 because the methods are going to remain same. So I am going to solve only one out of these two parts. Now we have to choose the values of A and B such that there will be two conditions. One is obvious, the difference between these two should be 15. At the same time, each must be a part of your table values. What I mean by that is, in the table, the angles present are 0, 30, 45, 60 and 90. I should choose the values of A and B such that they should be from the table. At the same time, the difference of this should be equal to 50. So either you can choose the values of A and B at 60 and 45 respectively because the difference is 15, or 45 and 30 so that the difference is again going to be equal to same as 15. In both the cases, obviously the answer is going to remain same. So we are choosing the values of angle A and angle B as 45 and 30 respectively. So now this is the formula given to me in the question itself. So replacing everywhere A as 45 here also as well as here, and B as 30 here, here and here. So I get cos of 45 minus 30 is equal to cos 45 cos 30 plus sin 45 into sin 30. And now substituting the values, this is obviously now cos 15, this is 1 upon root 2, this is root 3 upon 2, this is again 1 upon root 2, and this is 1 by 2. So the product is root 3 upon 2 root 2 plus 1 upon 2 root 2. Since the denominator is same, no need to find this separate LCM. So final answer is going to be root 3 plus 1 divided by 2 root 2. So the answer is cos 15 equal to root 3 plus 1 divided by 2 root 2. Now you can easily see for sin 15, wherever there is word sin cos is present, we will replace it by sin, and obviously the change of formula. Express each one of the following in terms of trigonometric ratios of angles A lying between 0 and 45. Now what exactly you mean by this? Both the questions are identical to each other, it's exactly same. Let us see the question first. Now, measure of this angle is not lying between these two numbers. even this is not lying between these two numbers. So what we have to understand is, we have to find out one expression which is equivalent to this, equal to this, but the angles should be lying between 0 and 45. Let us see how to tackle this. We have two formulas, sin theta equal to cos 90 minus theta and cos theta equal to sin 90 minus theta. So if I apply it, I get sin of 59 is equal to cos of 90 minus 59, which is cos of 31. Similarly, now using cos theta, it's sin 90 minus theta. Cos 56 is equal to sin 90 minus 56, which is equal to sin 34. So this expression now changes to replacing sin 59 by cos 31 and cos 56 by sin 34. We get it as cos 31 plus sin 34. Thus, is the measure of this angle lying between 0 and 45? Yes. Is 34 lying between 0 and 45? Yes. So we get sin 59 plus cos 56 as cos 31 plus sin 34. Now you can easily understand what is to be done. I'll be applying same cos theta is equal to sin 90 minus theta. So cos 75 will be equal to sin 90 minus 75, which is sin 15. Similarly now, cot theta is equal to tan 90 minus theta. So cot 75 is equal to tan 90 minus 75, which is tan 15. So once again, the expression will be equal to replacing cos 75 by sin 15, cot 75 by tan 15. So we get the answer as sin 15 plus tan 15. Is the value lying between 0 and 30? Yes. Is the value lying between 0 and 30? Yes. So in both the cases, we were obtaining the value of the given expression in terms of some other expression such that the angles will lie between the given two numbers. Here it was between 0 to 45. Here it was between 0 to 30 degrees. So pretty simple question, right?